Welcome back to the Complete Database Developer course. In this video, we will talk about the types of database and their characteristics. So let's get started. The first type of database is the single-user database. It is the database of the software which is built for the use of a single user, like a desktop application. Then, we have the multi-user database. Such databases are mostly used in the workgroup or enterprise databases. The only difference between them is that the workgroup database supports a small number of people, and the enterprise database supports a large number of people. Then we have an important type: the centralized database. It is the database of a system which keeps all of its data in one place. For example, if a bank has multiple branches, but it keeps its data in its main branch only, and the other branches fetch the data from the main branch via a network, we can say that it has centralized database. On the other hand, if the bank decides to distribute its data among the branches, like it gives the data of a certain area to its branch of that certain area, we can say that it is a distributed database. Now let's discuss a couple of important topics which are often asked in the interviews and very likely in the exams as well. OLAP is an approach to answer multi-dimensional analytical queries swiftly in computing. An example of its use is to summarize sales data by product, region, and time period. On the other hand, OLTP is a category of data processing that is focused on transaction-oriented tasks. It typically involves inserting, updating, and/or deleting small amounts of data in a database. It is mostly used in the ATM machines. Now, let's discuss the functions of a relational DBMS. Its main objective is to guarantee the integrity and consistency of data. It has several functions, such data dictionary management, which is the definition of the data elements and their relationships are stored in a data dictionary. It removes data and structure dependencies. Data storage management provides structures required for data storage. Data transformation and presentation relieves us from the distinction between logical data format and physical data format. Security management keeps the data and the transactions secure. Multi-user access control allows concurrency and better performance. Backup and recovery management prevents the possibility of losing data. Data integrity management makes sure that there is no redundancy of data and every datum is unique. Database access language and application programming interfaces are the query languages, such as DDL and DML. Alright, so let's talk about the database models. It is a collection of logical constructs used to represent data structure and relationships within the database. It has two types. Conceptual models are the logical nature of data representation. It emphasizes on what entity is presented. It is used for database design as a blueprint. Implementation models emphasizes on how the data are represented in the database. Conceptual models include Entity Relationship Database Model and Object-Oriented Model (OODBM). Implementation models include Hierarchical Database Model, Network Database Model, Relational Database Model, and Object-Oriented Database Model. Relationships in conceptual models are one-to-one, one-to-many, and many-to-many. We will study them briefly as we go through the course. Okay, so let's talk about the types of the database models. The first one is the hierarchical database model. As the name suggests, it contains data in form of a hierarchy or a tree. It is logically represented by an upside-down tree. Relationships in such a system are children and parents. Each parent can have many children. Each child has only one parent. A single table acts as the root of the database from which other tables branch out. For example, there is a table of a person's information. It contains his first name, a middle name and the last name. His address with house number, street number, city name or zip code, and the country name. To keep the table simplified, we create separate tables for the columns which have multiple entires against them. So we make another table which contains the first name, a middle name and the last name in 3 different columns. And another table for different columns of a complete address. These tables belong to the person, the original table. So the person is the parent table which is the root. The name and address are the children table. Bank systems commonly use this database model. As customer account can be subject to many transactions, which is a one-to-many relationship. The relationship is fixed, and the user frequently accesses large amount of transactions. Its advantages are conceptual simplicity. The relationship between layers is logically simple. Also, design process is simple. Database security is enforced uniformly through the system. Data integrity, as we talked about earlier. Data independence. The data does not depend on some other data to tell its complete value or information. There is efficiency in one-to-many relationships and when uses require large numbers of transactions. It also has some disadvantages, as in complex implementation. The physical data storage characteristics are disadvantageous. Database design is complicated. It is difficult to manage and lack of standards. It lacks structural independence, as one part of the system might depend on its parent or child. There are implementation limitations. In other words, it only handles one-to-many type of model. Coming to the network database model. It simply consists of a network structure. In this database model, each record can have multiple parents, which are called by database task group (DBTG) to define standards. There are 3 crucial database components in this model. Network schema, which is the conceptual organization of the entire database. Subschema. It is the portion of database's information for application programs. Database management language, which is the defining data characteristics and data structure. Schema data definition language. It defines schema components. Subschema data definition language. And data manipulating language. It manipulates data content. In this model, each record can have multiple parents. We need to introduce set to describe relationship. Each set has owner record and member record. This concept is parallel to parent and child in hierarchical database model. A member may have several owners. Hierarchical model is a subset of the network model. The network model uses set theory to provide a tree-like hierarchy. The advantages of this model are as follows. This model has conceptual simplicity, just like a hierarchical database model. It handles more relationship types. It provides data access flexibility, as the data is accessible more easily and with less restrictions. It promotes database integrity and data independence, and it conforms to standards of a good database system. Its only disadvantages are system complexity and lack of structural independence, as it is developed by the computer programmers for the computer programmers rather than user. So it can take some time for a normal person to understand it. The most commonly used database model is the relational database model. It allows user or database designer to operate human logical environment. It is perceived by user as a collection of tables for data storage, while letting RDBMS handle the physical details. Tables are a series of row-column intersections. Tables are related by sharing common entity characteristics like foreign keys. It allows one-to-one, one-to-many and many-to-many relations. In simple words, the relational database allows tables to have relationships between them by sharing common entity characteristics. We will study the relational database in depth in the next video. And this is the model that we will be working on. Its advantages are structural independence. The data access path is irrelevant to database design, which meaning changing structure will not affect the database. It has improved conceptual simplicity, as the user only has to worry about the relations between the tables, which are quite simple. This model allows an easier database design, implementation, management, and use. It allows ad hoc query capability with SQL. It is a powerful database management system. So that's it for this video. As I said, we will study the relational database model in depth in the next video. But before you go, I have a small task for you. Head below the video and press the red button. Subscribe to my channel and you'll be getting a lot more videos like this to help you with your exams and your interviews. Thank you. See you in the next one.